In this first example here, we're given that side AB is congruent to AC. So as soon as I mark those, I recognize that this has to be an isosceles triangle, which means that these base angles have to be congruent. And then I know that angle A is 30 degrees, so I'm going to label that. And we're trying to find the measure of angle ACD, so this angle right here. So the first thing I'm going to do is find these congruent base angles. So I know that in a triangle, all three angles add to 180. So if I do 180, subtract off 30, I get 150. And then I need to split 150 evenly between those two congruent base angles. So I divide it by 2 and I get 75. So that means each of these angles is 75 degrees. So now if I want to find this angle ACD, well, these two angles form a straight line, so they have to add up to 180. So I'm also going to do 180 minus 75, and we get 105. So that means the measure of angle ACD equals 105 degrees. The next example here gives you the coordinates of triangle RST, and we want to know what type of triangle. So the first thing I would do is I would actually plot the points so that you can kind of see what shape you think it is, and then just verify it using some formulas. Otherwise, you'd have to um, do more type of calculations. So let's go ahead and just plot this first. So I have -2, -3. It's going to be R. 8, 2, so 2, 4, 6, 8, up 2, and 4, 5. 1, 2, 3, 4, up 1, 2, 3, 4, 5. So as soon as I plot this, I'm seeing what looks to be a right angle at angle T. I don't know for sure until I actually do some calculations, but it looks like we probably have a right angle at angle T. So in order to know that, there's a couple ways that you can do this. You could do Pythagorean theorem. You could find the distances of these sides and then see if the numbers work in Pythagorean theorem. The quicker way, since we only care about knowing if this is a right angle, is going to be to use the slopes to find the slopes of the sides that make up this right angle. So I'm going to find the slope of RT. And to do that, I'm just going to count. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. So it's up 8 and then over 1, 2, 3, 4, 5, 6. So that means the slope is up 8 over 6. Remember, we always want to count to the right with slopes. So then that means it's positive 8 over 6 since I went up. If you reduce that, divide the top and bottom by 2, you're going to get positive 4/3. And then if we compare that to the slope of TS, well, starting at T, I had to count 1, 2, 3, down 3. So the slope of TS is down 3. And then over 1, 2, 3, 4. So since it's down 3, it's going to be -3 over 4. So that means that these two slopes are negative reciprocals, which means that RT is perpendicular to the segment TS. And that means if those lines are perpendicular, that means angle T is a right angle, because perpendicular lines form right angles. So that means we have a right triangle.